Hello, Keith Rucker here at VintageMachinery.org. Guys, today I'm over here at my Lucas horizontal boring mill. This is a machine that I've had in the shop now for a couple of years and actually have gone through and done a restoration work on it. It still needs a few little tweaks done here and there, but we did come in and re-scrape the bed on it, re-scrape the table, got this thing tuned up. This machine is over 100 years old. When I got it, it had a lot of wear in the bed. We went in and fixed all that. It was a lot of work. There's a whole set of videos just on rebuilding this machine. At some point in time, I would like to rebuild the spindle on this. With the bar that comes out, it's got basically where you can expand this quill in and out for doing boring. It will do all kinds of neat things on this machine. I really haven't utilized this machine as much as I would like to. And the simple reason is that it's just been, I haven't had the proper tool holding to make it easy to use. This machine, as far as putting, cutters, end mills, whatever in this, you basically got a spindle here that has a number 5 Morse taper in it. But because you can use this for things besides just drilling, like milling and boring and things like that, there are some things you have to take into consideration on the Morse taper. Normally on a Morse taper, I can put a chuck in here, number 5 Morse taper chuck, I've got one. All the pressure is pushing into the taper, so it stays in here nice and tight, no problem at all. When you're milling or doing some boring or some other operations, particularly if you're pulling on that, you can pull that taper loose while you're running it. And that's kind of an issue with using these types of taper systems. They're great for when you're pushing against the taper, but when you're pulling out, you can actually pull it loose and cause problems. And because of that, I really haven't used it that much. Now, they took that problem into consideration when they built these, and basically there is this was originally designed to use with a wedge system where you could wedge a cutter in here where it can't come loose. And I'm going to kind of bring you over here and kind of show you how this works so you can kind of see what's going on. And then I'm going to talk a little bit about my solution to this problem that I've had. So let me zoom you in here a little bit closer. So this is the spindle that comes out. And again, it got a number 5 Morse taper in the end. Morse taper basically looks like this. You guys have probably all seen a Morse taper before. Use it on lathes. They were used on drill presses and so forth. Here's a drill chuck. It fits up into the spindle, and that taper will lock itself in there pretty well. But again, when you're drilling with this, the pressure is pushing into that taper, so you're really kind of making it tighter. To get it out, there you got this hole in the back. And basically you use a drift key such as this little tapered plug, the tapered key. You can drive that in there, take a hammer, knock that, it'll knock your taper loose, and that's how you get it out, so in and out. Now if you notice though, there's another hole up here closer to the front, and on this particular item, it just goes right into the taper. Let me see if I can move that down a little bit where you can see it a little bit better. Again, you put the Morse taper in here. This is where we drifted out. We got this other hole here. So this was designed to address that issue I was talking about a while ago, where if you want to lock it in here. So this is a Morse taper, and if you look, there's a little hole in there. Put that up in there, and these holes match. So originally, the way this was designed is that you would take a wedge and you would drive it in there, and that wedge would basically lock it in where it would press against one side so that it was pulling it in. So in this case, you would drive it in, and ideally your wedge would be, this hole would be all the way up past the front here, and you'd have it back here. You drive that wedge in, and it jams it in there, and that way you can't pull it out unless you knock that wedge out. The problem is that I've got a bunch of tooling with the hole in here, but the holes are all kind of different shapes and sizes, And with this one right here, you can't really use a wedge. If I was to drive a wedge, this whole oval hole is smaller than the one up here. So if I wedged it in there, it's not going to keep it from coming out. Let me put a different one in here and show you. So again, if you look up inside of there, you can see that the inside piece is below this outside piece. I believe that this originally would have been a smaller oval, so that you had just a piece that went in there, it would touch this surface first and you pull it in and the bottom surface wouldn't hit it. We're just going to notch out around that to get around it. I'm going to make a custom one to fit. Let's get it knocked out. Let's make this part and put this in here. So just to kind of give you an idea, this is what the keeper key that the Vlig, or however you say that, sells that goes with this. And again, normally it would just be straight across. We're going to make a modified version of this that basically has a notch in the center, so that it'll fit into on my particular machine. But basically, that is what we're going to build. Let me sketch out. I'll actually sketch out what we're going to actually build. But you kind of see this is what an original one looks like. And like I said, these are commercially available. You can order one of these right now. That's $115 for that. And if you got the, let's see, let me go back. Here is, there is my Kwik-Switch 300 master holder that I've got. This one is without the keeper key, which is basically what I've got. You can order a brand new one, $990. And of course, you got all the tooling that goes in there. There's plenty of different tools that are available. And you can go order this stuff right now. So I've just kind of sketched out what we need to do here. This is going to be made out of some 1/2-inch thick material. I've actually got a block right here that we'll make it out of. This just happens to be a piece of steel that I found laying around. It was almost the right size. I'm going to have to do a couple of modifications to the length and all that, but it's the right thickness, and we can work with it to make this part. So I think what we're going to do is head over to the milling machine and start removing some metal here, getting this like we need it. So according to my drawing, this needs to be 1 3/8 inches. We're at 1.5 inches right now on the thickness. So I need to take a little bit of material off of that. Let me go ahead. We're going to put this over here in the vise on the mill machine. I got a parallel up underneath the bottom, and we're just going to get that cut off. This is not a critical measurement. It just needs to be around 1.375. So I'm just going to come in here, we'll touch off on that and just mill that surface down. I'm just going to drop my cutter down till it touches. Again, this is not a critical measurement. I'm not worried about having it exactly that measurement. I'm going to zero out my Z-axis, and I'm actually going to put in 1.5, and we should be able to keep track of where we're at and take the 1.375. All right, let's raise the table up a little bit. And we'll just cut across that. Been about 50 thousandths per cut here on the depth. That should have that milled down to the right size. Yeah, we're about 372, so we're within a couple of thou there. I'm going to take this to the belt sander, just deburr that real quick. The next thing I need to do is take it to the proper length. Right now, what are we at? We're about 3.120. I need to go to 2.875, so we need to shorten this up a little bit. Let me go deburr that, and then we'll shorten it. I just do roughly 50 thousandths per pass until we get it to the right length. right, that's 3.875 right there. Taking a little light cut there. I'm going to lay this part out. I need to cut that notch in the top, so I'm just going to take some magic marker here in lieu of layout fluid, although my marker's getting kind of weak. There we go. You get grab a Sharpie here. Let that dry just a second. So I need to cut a notch in here, and I'm just going to lay it out. I've got the size need to be, what is that, 0.5625, so I'm just going to take this. We'll use my calipers. Just put a couple lines in there, and then this needs to be 0.375 deep. And again, this is nothing real critical. I'm just going to basically put it in the mill and cut it to the lines, because again, this is not a precision. There's no reason to go to a bunch of trouble. I just need a notch there for clearance. And put a parallel back in here for that to sit on. Chuck that into the vise. And we're just going to nibble that out. I'll take that down. Again, I'm going to call that 0. I'll zero out my Z-axis. I can at least keep track of my depth of cut there. And about a 50 thousandths depth here. I'm just going to kind of take it over that line. About 0 there, and the depth, we'll just got it. I'm going to take this, deburr that, and we'll continue on here. Now on this top side, I need to kind of round over the top. It needs to be kind of a 1/2 inch radius, or actually 1/4 inch radius, 1/2 inch diameter, bull nose across the top. To do that, I've got a rounding over bit in here, and we're just going to mill down through there. And get that rounded over. So let's see here. Round that right over there. Go a little bit deeper. All right, that's not quite over to a full radius, but I'm going to, if I need to finish it off, I'll probably just do it over on the belt sander and touch it up. Let's go try this out though first. So let's see where we're at here. We got our key cutting out here pretty good. That fits up through there. It notches out just fine. Now, I've got a round in the top of that, and this is square, so we're going to have to round that over. Unfortunately, that's not wide enough to do on my belt sander, so I'm probably just going to have to take a file to it. I can't really get in there and machine that. No big deal, it won't take long. The other thing I got to do is drill a hole through there for my set screw or cap screw to get into. It's a 1/4 threads. I've already center punched the center roughly. Again, it's nothing precision critical here. I'm just going to go to the drill press, drill that with a number 7 drill bit, and then we'll just tap that hole. And I'm just going to file that out to fit, and I think we'll be where we need to be. All right, let me finish this up. Got this over in the vise, and I'm just going to put a pretty good little glob of anchor lube down in that hole. Brush some on my tap as well. And this is a 1/4 tap. That was a number 7 size hole, which is the drill size for a 1/4. And we'll just run this tap down that hole, and I'm going to probably just go until we come out the bottom. Or my tap bottoms out, whichever comes first. Here we go. Here's our threads that came out the bottom. And now comes the fun part. I'm going to round that over. Whoops. I'm just going to take a file and we'll work this in there. One side at least started good. I'll do this side and then go test fit. I may have to take a little bit more out of there, but we'll start there. Well, guys, I think we've got our key made. In full disclosure, I had to come in and take this a little bit more out of the middle. It wasn't quite touching up here in the top, so we just made that a little bit deeper. This key fits down in here, fits up over that, and I believe now we can put there's a little bit of play in there, which is what I want. This is a little bit smaller diameter. It should go all the way up into the spindle, should clear all out here. We just need to put our screw in there and tighten it up. I think before I do that, I'm going to round these corners over on these outside just because that is a radius out there. Just soften them up a little bit. So I'm going to go with the belt sander and do that real quick. And then we'll put our socket cap screw in there and see if everything works. All right, let's see what we can do. Put the key back in here. Got my cap screw in here. It is now engaging into the bottom. And we are drawing that up. And that, I believe, is going to work just perfect. That is locked in place. My key is below the surface on either side. Now we can put our tool in here. Lock it in place. Take them right out. So that's a quick, easy way to change tooling out. That is spring loaded, so you just kind of push that in there and lock it in place. All right, I'm happy with that. So now probably what I need to do is just check this for run out, make sure I don't have any significant run out in that. But this will make changing tools much easier. Again, I do need to get some more of this Kwik-Switch 300 tool holders of various sizes and asunder. Again, if anybody has a stash of these laying around in the shop that's not using them, let me know. I would be interested in acquiring them. So anyway, let me see if I can find something, and we'll just check run out real quick. Let's just start by looking and see what kind of run out we got in the spindle period. Again, this is a 100-year-old machine. This spindle is not perfect. I know that going into it, but probably good enough for the work that we'll be doing on it. And you know, for most things, milling and things like that, it's not that critical even if you got a little run out, because it'll work its way out as that cutter's going around. Anyway, ideal, no. Perfect, no. But acceptable, probably. I've just got a Morse taper cutter up in, or arbor in here. This is a nicely fresh ground one that will give us a good idea of what kind of run out we got in here. And I'm just going to turn the spindle on, and it's between 6 and 7 thousandths of an inch. So again, not perfect, and we might be able to clean that up. I might be able to take a Morse taper reamer and put up in there and just kind of clean that spindle up. I don't have a number 5 reamer, but we may try to do that and see if we can improve that. But that's kind of where we're starting from. Well, I was thinking that I didn't have a Morse taper 5 reamer, but I went over and checked, and sure enough, I've got a Morse taper number 5 reamer. This is at the right angle and everything for a Morse taper. This is was in a set from World War II, so basically was a new old stock set of reamers that I acquired several years ago. Let's see if I can roll that around where I can see what's going on. So I was thinking that I did not have a Morse taper number 5 reamer. However, I went over and looked in my cabinet. I knew I had a set of Morse taper reamers. It's actually it was a new old stock set of Morse taper reamers that are marked US Navy, and they date from World War II. And basically all of mine were brand spanking new, still in the original wrappers when I got it. And I thought it went up to 4, but it goes up to 5. So I want to just bring this over here and see if I can, okay. Interesting. So the reamer bottoms out before it starts cutting. I don't want to do a lot of cutting with this, but I can just feel up in there, and there are little burrs and stuff in there from just years. So, yeah, makes me wonder what's going on here. So, I'm wondering, I almost need to make my hole a little bit deeper, or my reamer a little bit shorter. I hate to grind on that reamer. Let me look and see if I can find another reamer. This is a really nice reamer. Thought I'd just show this set of reamers. I found this, I don't even remember where it came from. I don't remember if a viewer found this or whether it was an eBay find. I really don't remember where it came from, but when I got this, none of these reamers had ever even been opened up. This thing was brand spanking new. I've actually used a couple of them now. This number 3 reamer is still sealed up. It has never been used. I think the other ones I've used. One set carbon steel straight flute Morse taper reamers finishing, US Navy reamer set number 3, type F number 1 through 5 inclusive, manufactured by the Millersburg Reamer and Tool Company, Millersburg, Pennsylvania, USA. And I did some digging back whenever I got this, and basically this was World War II era. It was made and went into a warehouse and never even got put on a ship, would be my guess. or if it was put on a ship or in a repair shop, it was never used. Anyway, nice set. Well, after sleeping on things overnight and thinking about this whole situation, I think that instead of ordering a reamer and grinding it down and everything else, that what I'm going to do is I'm just going to drill the hole out in the bottom of this taper a little bit deeper where I can get that reamer to go down in there. So I measured the small diameter of the piece to go up in there. It was basically just a little under 1.5 inches. I went and found a drill bit over in my stash. This is, what is this? 1 31/64, which is a 64th of an inch under 1.5 inches. This happens to be has a Morse taper 4 fixture or holder on the end. So I dug around and I actually had a holder that goes on my DA Aloris tool block that holds a number 4 Morse taper. So I'm using that as a tool holder to hold my drill bit. It fits up in this nicely. I got it clamped down to the table, and basically I am converting my horizontal boring mill into a lathe right now. This is becoming my tailstock. Of course, this is a lathe spindle, and I'm actually working on the spindle itself. We're going to just extend that hole. It doesn't have to be, probably 1/2 inch deeper, and I should be able to get that reamer in there and go. And just what I think here, just for clarification, what I think has happened is that at some point in the past, again, this machine is over 100 years old. I think it was made in 1916, if I remember right. Or was it 1918? Anyway, before 1920, it's over 100 years old. I think that they have done this operation with a reamer probably multiple times, cleaning the spindle up. And because of that, it has gotten a little bit deeper into everything than what it was originally, and we're kind of bottoming out in there now. Another thing that I've noticed is that the spindle on the end, some of my tools actually hit before they bottom out. While I'm doing this, I'm probably going to put a cutter on here and actually turn this nose piece down a little bit, because again, it's just sticking out a little bit too far. We can make it work. I think everything's still going to be fine as far as the holes and stuff like that. We're going to have to make some accommodations for it, but we can make it work. So that's what we're going to do. I'm just going to drill this thing out a little bit deeper. Hopefully this works without any problems. Let's keep our fingers crossed and give it a try. And I think we're ready to start drilling. A couple of things here. I put a mark on here to kind of where I'm at right now before I start, so I can kind of keep track of how deep I'm going. I don't need to go very deep. You know, 3/8 of an inch, 1/2 inch max, we should be fine. I will note, guys, that the center hole goes way on back in here where the tang goes in. So I'm really only going to be cutting on the outside of that, but I need to open that up to go just a little bit deeper so that reamer can go a little bit deeper. I'm not drilling the center part though, I'm only drilling the outside. I did lock my spindle. There's a big hex key up here on the top. That just locks that. That will keep the quill from pushing in as I feed in on this. That's designed for anytime you're doing any milling or whatever, you can lock your spindle and keep it from moving. So we'll go ahead and do that. And I'll just bring my table in. And we're starting to get down in the bottom and cutting here. Stop here for a second and kind of get an idea of how deep I've gone. I've probably gone maybe 1/4 of an inch deeper. I want to go just a little bit more. Let's see where we're at now. All right, I've gone about 1/2 inch deeper. So I'm gonna go ahead and pull this out. I'm gonna put my reamer in there and see if we can get it to make a little cut all the way down into the bottom. And hopefully, I don't want to cut much. I just want to clean that bore up, because I can just feel up in there and there's burrs and things in there. So I'm just really just wanting to kind of just touch it up a little bit. So let me get this table out of the way and we'll give it another try with the reamer. So you can kind of hopefully see down in there. You see that little shiny area in the back. That's the little extra depth that we drilled. Here's my reamer coming in, and it's more or less touching down there in the bottom, or it's not touching in the bottom. I really just have clearance in the bottom. It's actually a little bit larger diameter than the reamer, but that's fine. I just need clearance down there because it was bottoming out. It was bottoming out before we were cutting anything. But now I should be able to turn that reamer a time or two and just clean that hole up. Let's give it a try, see what happens. I'm gonna put a little cutting oil down in there just to give me a little bit of lube. Take my reamer, take a wrench here, turn this. I'm not trying to go real deep. I just want to kind of just clean that up a little bit. Make sure we got a good taper in there. And I can look in there and I can see marks where it has removed metal, and I can definitely see some areas where it's cut off a little bit more than others. In fact, I'm going to take just at least a little bit more. Try to get a little bit more cleaner surface in there where it's touched up all the way down. I'm just giving a little bit of inward pressure on this as I'm doing it. All right, so hopefully you can see we got some shiny material in there. That should hopefully have just kind of dressed up that spindle just a little bit. I'm gonna get a rag and kind of clean that out a little bit, and then we're gonna put a tool holder back in here and check it again with the indicator and see if we made any progress or if we made it worse. All right, I have my good spindle in here. This is a brand spanking new number 5 Morse taper end mill holder. And I'm running on the inside of the bore, which is the important side. And my run out is about 1.5 thou. About 1.5 thou. So I basically took that from, I think it was 6 or 7 thousandths down to 1.5 thou run out. And on an old machine like this, I don't know that you can expect much better. I'm tempted to put my reamer back in there and maybe take just a little bit more, because I could tell it's not cleaned up in every spot in that spindle yet. Just looking at it, it's cleaned up, I'd say probably about 60–70%, but maybe I just take a little bit more and see if we can make it a little bit better. Heck, I think I'm gonna just give it a try. I'm not gonna hurt anything, I don't think. I don't think we'll get any worse. So let me see if we can make it a little bit better. All right, so I took another round in there, and I'd say that right now it's probably about 85 to 90% contact in there with the reamer. There's still a couple of places it's not perfect, but it's about as good as I can expect to get. And I think I did pick up just a little bit. I mean, we're now reading on the indicator. It's just a touch over 1 thou run out. Maybe 1 thou and a couple of tenths. I don't have a tenths indicator on here right now, and honestly, the run out that's in here is probably in the spindle, not in the taper. And we're probably not going to be able to straighten that out. So it's probably as good as I can expect to get. But I think we did make a marked improvement. So I've gone back to my Kwik-Switch adapter now, and here we got our next problem. Right now I've got this thing tightened up, and before it tightens up all the way, it's actually hitting the face of this. So again, with the reaming and go a little bit deeper, and the work that had been done on this previously and everything else, basically this nose is sticking out too far. So what I'm going to do is I'm going to put a tool cutter on here, and we're basically going to again turn this into a lathe. I'm just going to turn this back a little bit, and that should give a little bit more room for our tools to fit down into this socket. I've got some other tools that are bottoming out. I got one tool that won't even stick. This one's starting to stick, but it's not as tight as it needs to be. So I'm going to just kind of face the front of this spindle, shorten it up a little bit, and then we're going to check this tool for runout. So again, I'm going to basically use this machine like a lathe. I've got a tool cutter, in this case a boring bar, but it's got a tool bit in here. It's a lathe cutter now. We're going to basically turn the spindle, that'll be turning the lathe, and I will just feed in and then feed the table across to face that. And I want to take it back somewhere about back in here. I want to take a fair amount off of that to get me plenty of clearance, and we'll go from there. So I got my spindle speed set up a little bit faster and my feed rate a little bit slower. Feed across. We're going to take several facing passes until we get that cleaned up a little bit. So I've got my Kwik-Switch tool holder in here now. We've got it tightened down. Now you notice there's a gap in there. Before, this was basically coming up in contact with the front edge. It wasn't allowing that piece to go all the way back in there and seat in the Morse taper. We've got the clearance there now to do that. And I got my indicator in here, and I am very happy with the results. That's actually less than a thou of runout. About a half a thou. That is really awesome. Way better than I ever expected to get out of this machine. So let me put a tool holder in there now and check it with the tool holder in there and see what kind of runout we get there. All right, so I got one of my tool holders here. I'm gonna put it in. We'll tighten that up. I see a little runout on the outside, but I want to check it on the inside because that's the important surface. Bad news here, I'm getting about 10 thousandths runout on the tool once it goes in there. The actual inside of the cutter is running extremely true, but the tool holder isn't, and I actually tested another tool holder as well. And so what's going on? I think my tool holders are fine. Here's what I think. I think this cap piece that screws up on here is just jacked up. You can tell it's been welded on, it's been beat on, and I think that when you tighten that up, it's not pulling it straight in, it's putting pressure on more on one side than the other. And I think this is what's actually causing the problem. So the good news is that this is a replaceable part. This is a part that has issues when it's used for a long period of time. I can order a new, I forget what this piece is called, but I can order a new one. There's a kit basically to rebuild this. It includes this new collar and everything else that goes with it, the springs and whatever, and instructions on how to do it. It's about 300 bucks. Really don't want to have to spend that money, but I think if I'm going to use this, that's what I'm going to have to do. So again, this outer piece is knurled. Looks like it had been broken off at one time, and like I said, it's welded in place in a couple of places on this collar. Oops, you can see it there. There's a spring that kicks that out. And I think that's the problem because that's connected to this outer edge. That's what pulls that in. And it looks like this may have, I don't know if that was originally two pieces or not, but it was welded back together. And there's a couple of other places on this where it really looks rough. So, all right, yeah, spend more money. But in order to use this, that's what I'm gonna have to do, I think. So I'm gonna order that kit and see if we can get this fixed and make this a usable tool. 300 bucks is a bunch of money, but it sure beats 1,000 bucks, which is what a whole new tool costs. And with the runout on the inside being good, it's got to be this outside collar that's giving me problems. Well, a good news, bad news situation here. So the good news is that after doing some tune-up to the spindle, we've got the runout on the spindle thousandths of an inch. That's way better than I ever thought that I was going to get on this machine. I've assumed that this spindle had a lot more wear in it than that, and I had tested runout on this before and was seeing that, you know, a little bit of runout that we were seeing, like we were seeing about 7 to 10 thousandths runout was what I was seeing before. But it turned out that was in the Morse taper. And by making a few modifications and running that reamer up there and cleaning up the face where my tools are properly seat, I think we've got that worked out. And I am extremely happy with the improvements that we were able to make on the runout. Everything that runs on this machine is going to run on this Morse taper. So if I can, having that runout down to a thousandths of an inch or less, that's awesome. I can definitely live with that. Now, as for the tool, I think, again, that's the bad news. I'm going to have to invest a little bit more money into this Kwik-Switch tool to get it to where it can work properly. I'm also going to have to invest money into the tool holders to be able to have a good selection over here, but that's all, you know, it's just what you got to do. So, yeah, I think I'm going to order a rebuild kit for this, get a new nose piece for it, and hopefully have a good usable Kwik-Switch 300 tool holder. Going to be on the lookout for the actual tool holders. I said tool holders. This is the Kwik-Switch unit. These are the tool holders. I'm going to be on the lookout for some of these. Again, if anybody has any of these laying around that you're not using, shoot me an email, let me know. Here's my email address. I would definitely be interested in buying, trading, working out a deal or something to get my hands on some of these so that we can utilize this machine more often in the shop. Like I mentioned earlier, I really haven't used this machine as much as I could because of work holding. I feel a lot better where I am right now, and if we can get this going, I think this will become a much more useful tool going forward. Another thing that I want to do on this machine at some point in time is put a digital readout on it where I can really kind of follow what's going on it. This has dials on it, but they are extremely worn and hard to read. Again, it's a 100-year-old machine. I did a lot of work to this machine. It's actually, for a 100-year-old machine, it's in pretty dang good shape because we rebuilt the bed, we rebuilt the ways, everything like that has been done. The column was in really good shape. We didn't really touch it. You know, I had assumed at some point I was going to have to rebuild the spindle, but after doing the work today, maybe not. As we use this machine more and more, I think we'll get a better idea on how good it works. But there we go. That's where we're at. Guys, that's a wrap. As always, thanks for watching. Please do subscribe to the channel if you haven't already. Those thumbs up, those comments are always greatly appreciated. Hit that bell icon up there to get notifications when new videos are posted. And a big, huge thank you to those who support the site financially through Patreon, PayPal, as well as YouTube memberships. All those are great ways to help support the site and help bring more content like this to you. And with that, guys, I'm going to get out of here. We'll catch you on the next video. Again, as always, thanks for watching.